Hello everyone. Previously, we were successful in designing the multiplayer Sudoku game. So today we'll be solving or we'll be designing this one LRU, a static plus dynamic input flow. So nothing but the LRU cache. But let's see what the question states basically. So here we can clearly see design a recently used nothing but the LRU cache with this specification. Basically, the first specification is static inputs of fixed capacity. Also, the second one is dynamic inputs. Capacity can change at runtime. Here we can clearly see dynamic inputs capacity can change at runtime, and they have also asked extend the design for LFU with the minimal changes. So let me just delete this one. Let's go with the LRU, right? So what we have to do here, we have to design a LRU cache with static inputs, fixed capacity, and the dynamic inputs, nothing but the capacity that can change at runtime, right? So I'll just explain quickly what are all the things that we need to consider and what are all the things that we need to do. So here LRU, nothing but the least recently used cache. This one evicts the least recently used items when the cache reaches its capacity. So just keep in mind this one. So LRU evicts the least recently used items when the cache reaches its capacity. This is the first thing that we need to keep in mind. Second thing, we can just make use of the combination of a map and doubly linked list for the efficient operation. Let's see that one while we try to implement the same thing with the in the form of code, right? So we'll be making use of the combination of a map and doubly linked list for the efficient operations. Also, if we are considering the LFU, so we can just track usage, frequency, and evict the least recently or least frequently used items, right? Let's ignore the LFU part. So let's go with these two things. So just keep in mind, LRU evicts the least recently used items when the cache reaches its capacity, and also we'll be making use of the combination of map and doubly linked list for the efficient operations, right? So let's try to implement this one in the form of example. The programming language we'll be making use of here is obviously the JavaScript, right? So as we are going with the LRU cache, I'll just name this one class LRU cache, right? So within this one, I'll just make use of the constructor. So, and within the constructor here, let me pass the parameter capacity. So I'll just give here capacity, right? So here, let's initialize the capacity. So I'll just give here capacity. Let's set this one to the capacity. Also, I'll just give here cache to the map. Nothing but here we are storing this one by making use of the map. We are storing in the form of key value, right? So we need the key value stored. That is the reason we are making use of the map here. So we are initializing the cache to the map here, right? And also we are initializing this one capacity. We need the capacity, so we are making use of capacity. So I'll just come out of the constructor here. So let's make use of two methods. One is get and another one is put. These two are enough basically. So let's see. First, let's go with the get method. Within the get, I'll just pass the key as a parameter. So we are making use of the map. Basically, we are making use of the key value. We are storing in the form of key and value, right? So here, I'll just be making use of the parameter key. Initially, let's see if the cache has the key, then what we will do, we will just return -1. This is fine, and let's set the value to the get the value based on the particular key. So based on the particular key, we can get the value of it, right? So I'll just make use of get here. I'll just give here key. So if you don't know what we are writing here, if you don't know the map and operations, I mean the properties of map and hash map and hash set. So please do go through the playlist that we discussed basically in the JavaScript playlist, right? So JavaScript concepts playlist, I have clearly explained about the hash map and hash set along with the properties, as well as we have considered examples as well. You'll understand this one crystal clearly. So whatever I have been writing here, the code. So the next line, to delete the particular key, I'll just be making use of cache. Let me make use of the property delete here. Delete key, right? So along with the key, the value will also get deleted based on the particular key, right? So after that one, we have to move to the end. So I'll just be making use of move to the end, nothing but we have to update, right, the key and the value. So I'll just be making use of cache dot set here. So I just give here key value, right? So this is fine. Finally, let's return the value. So we have to return the value, right? So that is the reason I'll just give here return value. So this is it for the get. Next, let's go with the put method. Within the put, let me make use of the key and value as the parameters. So first, I'll just quickly write the simple if condition here. If cache, same thing here, the first one I should have copied the same thing. If it has key, so if we already have the key, then we will be deleting that one, that key, right? So I can write in this way: cache delete of key. So then let's go with the else if the size of the cache, nothing but I can just make use of the size directly, right? If the size of the cache is greater than the capacity, so here capacity that we have considered here, you can click clearly see here, right? If the size of the cache that is greater than the capacity, then what we can do, we can delete. I'll just give here I have to make use of cache right here. I forget this one every time. So I'll just give here cache dot delete. Let's delete the cache keys and move to the next value. So how can I write this one? So simple, right? Here I just make use of cache dot keys. Let's delete this one and move to the next value. So I'll just give here next value. It's not a function, it's just the value, right? Size and capacity, size and value are not the functions. You have to just keep this one in the mind. So here what we are doing here, we are evicting the LRU, right? So while explaining, I had already said during the explanation. So LRU evicts the least recently used items when the cache reaches its capacity. So that's what we are writing in this line. Again, I'm telling this line is very important here. LRU evicts the least recently used items when the cache reaches its capacity. Here you can clearly see when the size of the cache is greater than or equal to the capacity, then we are deleting based on the keys right here. We are making use of the delete property and we are deleting the keys and moving to the next value. Nothing but we are evicting the LRU. So I mean, yeah, we are evicting the LRU. Finally, after this step, let's update the key value. Nothing but we'll be making use of the set. So I'll just be giving here set property, right? Within the map, I'll just be giving here cache.set of the parameters, nothing but key and value. So this is it. So I'll just format this one. So this is it for the this one. This is the solution basically. Let's see the this one test case, right? So test case or the usage, I'll just give here test case or the, we can consider this one test case or the usage. I'll just consider variable name LRU. Let me set this one to the new LRU cache of, let's pass some random number. So I'll just give here 2, right? So by making use of put here, we can clearly see here, we have to pass the key and value in the put, right? So I'll just come here. Let me give here LRU put. Let's call the put method here. I'll just pass here 1, 1. Again, let me consider put method here. Let me call the put here. Again, let me make use of 2, 2 here. Finally, we have to get the value. So I'll just log here LRU by making use of get here. Take the get property. I'll just give here 1. So output that we need to get here is 1 itself. And again, let me make use of the, I'll just come here. Let me make use of put here. Let me give here 3, 3. So here this gets evicted, nothing but the 2, 2, which is recently used. Basically, we are evicting the 2, 2. And finally, if I log something like, I'll just give here, in my case, I'll just come here, console log of, we have to get the value, right? LRU dot get and make use of, and let me pass the 2 here. So this one, we are evicting 2, 2. Then I log the value of 2 here. Second one, console log LRU dot get of 2, whatever I'm doing. So this time we have to get the output -1. Here will the output will directly get 1. You can clearly see the value is 1 here. And 2, what we are doing here, we are trying to get the value of the 2 basically here. And here in this step, whatever I am doing here, we are evicting this one, right? 2, 2, this one. So here we will get the output -1, nothing but not found, right? So for the not found purpose itself, I have made use of the value -1 basically. So I'll just format this document once. Let's try to run the code. Let me give Ctrl J here. So let me copy this one second, the name. Let me give here node file name.js. So what happened here? Let is not defined. Line number 34. So yeah, here this has to be LRU, right? Why I have given here? This is fine. Let me clear this one. Now what I have done wrong here? Let is not defined again. Line number 37. Oh, why this is considered let here? This is fine. So yeah, let me run this one again. Yeah, now you can clearly see, as I've said, the output will be getting here as 1, and we are evicting 2, 2 here, this one, based on the key. So this one gets evicted, and the value that we get here, while I try to get the value from the 2, so here I have to get -1. This gets evicted in this step, right? So the value that I need to get here is -1, nothing but not found. Here we are getting 1 and -1, which is absolutely correct. This works. This code works absolutely correct, right? Now we have designed the this one LRU with static inputs, nothing but the fixed capacity, as well as the dynamic inputs. Capacity can change at the runtime. This one, basically, we have successfully designed this one. So next, let's discuss and try to solve the, let's try to design the in-memory cache, right? For now, this is it. Thanks for watching, guys.